Don Griffin, me, Centricon, and Twitter. All right, here we go. So view models and data binding. Not a totally new concept, but there's an awful lot of details, and so we'll try and get through as many concepts and drill-ins as we can. If we have time, we'll do some tinkering in the debugger and kind of see how things behave. But I'm going to dive in and ask the simple question, why view models? And probably if you're here, you have at least some answers already in mind. Obviously, the big one is to automate the connection between your data and your view. So please don't make me write code to take data out of my data model and then set it into my view or the reverse. Because what can happen is the data gets out of sync in the view if I change it in my model and forget to do that, or it can get out of date if the user types and I didn't listen to the right event and didn't get it back into the data model. So this is really what it's all about with data binding, is keeping these two worlds in sync, the view and the model. So the other very obvious thing is that it becomes declarative instead of imperative, so you can look at your view and have an idea of how the data that satisfies that view arrives and where does it come from, what's it called, and so it's a much more easy way to look at how the things connect from the model up to the view, who's dependent on what. So the necessary picture, simple picture we've seen before is the view and the view model relate. And if you were at the last session, you saw the model can exist all the way down from records to stores to sessions. So it can span quite a continuum. And the view model knows how to talk to that, but the most interesting part is how the view model is related to the view via binding, and how that relationship is established and how you can take advantage of it. That's the focus here. So we'll dive in on the using side. So view models obviously have to exist, they have to be populated, but once they're there, this is probably the side that you'll interact with the most by large amounts, is how do I pull data from it? And binding can be done directly, but when you get started, there's a few key concepts that you want to do, that you want to have a mastery of. So let's get right into the basic ideas that you'll need to have a grip on. Binding descriptor is just a word to say what the value you want. So it kind of is an intuitive thing. You say, I want my text to be this. What you're saying, the this is the bind descriptor. And we'll see how interesting those can get. The bound value, of course, is the result of the bind descriptor. And this is one of the key aspects of view models in EXTJS, is that data is presented as the bound value when it becomes available. So if you have to load a model, load a store, traverse things, that can take a moment, can take AJAX calls, but you don't want to express those things in the view. You just are going to be told when the bound value is available. So it's a key thing to remember, it's asynchronous. And again, it's not just a one-time thing. Tell me about the value. It's tell me when that value changes. So if I set a bind, I want to know that it's current. So right down at the bottom of the stack of control components, there's a view model. We can create one directly if we want, and there's a lot of things it can do for you, even if you're not using it in a view. So we'll just start with these concepts and see how can we do a bind directly to the view model. So if you have a view model, you call its bind method, and this is that bind descriptor. That's the bound value. And the last piece, B here, that's the binding instance. So the binding instance is just created, and if you're doing this directly, you're going to want to hold on to it. We'll see in the next step or two. So the first thing we'll do now that we're bound and looking for this foo, we're going to set foo, and what that does under the covers is it just marks any interested party as dirty. And we'll see how that comes together, but it doesn't immediately call the bound function here. It just says, okay, foo's dirty. We'll get back to that. And then as soon as has a time to run, we'll get our console log statement out. Now the interesting part here is that this is direct in a couple ways. We're directly talking to the view model, but we're also in the foo binding over there. We are directly talking to a single value. There's no formatting, there's no anything additional than just the foo name. So what that is a direct value. And 42 comes through there not as a string, but as the number 42, because I set 42 there. So if that was an object, it would have come through as an object. It wouldn't have been stringified. So that's important because direct bindings are two-wayable. You can put back the value as well. So that's direct in multiple ways. And this is one of the reasons when you're building direct to the view model, you would need that binding object, because you probably will need to clean it up at some point. So if you're used to listeners, it's kind of on and un, or listen and unlisten. You add and remove listener. That's what we're accomplishing directly here. So start looking at some of the other forms of direct binding, or how binding can be performed with this. This is a new kind of bind descriptor. And it's really the only algebra we support inside of here. But the reason is probably obvious, because a lot of times you're going to want to bind disabled to something or hidden to something. And so it's extremely common need to want to negate something on the way in. And this will produce a Boolean value, because you also don't want to pass an object in. So this is a negated descriptor. When we set it, we'll see false, because not world is false. This is where we're starting getting interesting, binding templates. Now we're putting more stuff in that string. So it's not just a direct value, but a template. And you can see you put text around the replacement token. You can use formatters. And when you get that bound value, it's going to have the capitalized variable for X and then the string around it. Now this one is going to put both those concepts into an aggregate, like an object and an array. And instead of going through both, we'll just see both of them in this one example. So this bind descriptor is an object with two properties. The first one is a string. The second one is an array with a direct binding to Y. So when we set X in there, nothing's going to happen immediately, because that bind descriptor isn't satisfied yet. It needs X and Y. As soon as we set that, we're going to get an object that's shaped like our bind descriptor, with the replacements all put in place and the value 13 passed straight on through again. So those are the basic forms of bind descriptors, and as you can see, they can be useful for an awful lot of things. We'll see how view models take advantage of these for your application defining stores and other things later. So sometimes, though, it's important to be able to configure the way the binding works. So if you've ever done a listener, sometimes you'll say single true or something like that. There are options that govern how the binding itself behaves, and that's what this last argument is the way to specify how that binding should act. Normally, a binding is just going to look at the property that you ask, and when that property changes, you get told about it. But if you care about an object underneath, say foo has properties, and you care to know that some of those properties are changing, you might want to set up a deep binding and say, I'm binding to foo, and tell me when anything underneath there changes. So obviously be aware that the deeper that object graph goes, the more expensive it might be to track it down, and you might be called for all kinds of things, but that's an important thing to note. That's more commonly needed if you want to, say, address a record, and you want to know when any of the fields of the record change, because you're going to run it through a template or something to format some HTML. You'll want to say deep on that record binding. You can also say single. Maybe you only want the initial value. That's probably not terribly common, but I've definitely bumped into this when we're building controllers and we want to know, I need this particular thing. I don't know when it's going to be available, but call me when it is, and then I have what I need. Again, it's a once available thing, so that could take a moment to resolve. And lastly, the last binding option is this one. So most of the time, if you put a binding on a form field and that form field is editable, and the binding is direct like this, it has the ability to poke the value straight back into the view model. But maybe you don't want that. Maybe you want that binding to be a one-way binding, so you can configure it to be not a two-way binding. And now that binding is marked read-only, and edits don't get pushed back. So basically, those are the bind options. And we'll see the fourth argument here, but we'll see how it works when you get to components in just a moment. So now that we've kind of surveyed those different descriptors and how they look, it's time to get a little technical on how these things actually come together. So the binding descriptor, we've seen that. It's the data that you want. The binding token is these replaceable parts. It's the things inside the curly braces, and they can be as simple as our normal template, which is just a property, but they can also be a dot path. and we'll see here that a dot path starts at the root of the view model. Could be something simple like ticket. Maybe if you saw the previous session, we put a ticket in the view model. But we don't want just the ticket, we want ticket.reporter.name. So it's going to traverse that thing through dots. And then the bound value, again, it's delivered as soon as that can be delivered. So to summarize, what is a bind descriptor? Kind of a formula for it. It's a string with one token. It's called a direct bind. It's a string template. It can have objects, and the values, or each of the values of the object are interpreted as bind descriptors, so this is a recursive definition. And arrays, their elements are interpreted as bind descriptors. So anything you can pass to bind looks like that is going to produce a bound value that looks like what you gave it, but with all of the bound values replaced. Okay, so the tokens, seeing the simple top level one, the dot path, as I mentioned, ticket.reporter.name. So that's an interesting one because that one is an association as well as a property access on a record typically. So record, association, field, but I don't have to specify all of those individual steps. The descriptor understands how to take that apart. You can include formatters. Formatters can have parameters. You can negate them. So those are the individual tokens, and again, they can occur anywhere inside your descriptor. All right, so dot paths. Simple ones to start at the top. So if you had to put a record into a view model, or you reached a record, you don't want to have to say record thing.data.name to descend the data property. You just want to have record.name. So in the traversing of a dot path, we understand when you encounter a record that your property name here is going to be looked at as a field first. But more importantly, it also understands associations. So reporter here is a one-to-many. There can be many tickets that you report, but a ticket only has one reporter, and so we can traverse that, and the ticket.reporter part of the dot path will become a record, and then the name field of that record is what you're going to get. So the bound value, again, as I mentioned, if you have just the one token, that's going to be the exact value from the view model, and that's important. The object identity is preserved. It's a record. It's going to be that record instance, not anything else. If you put a negation, it's a Boolean negation of whatever the rest of the token was. All of these will be replaced, whether in the value of an object or in an element, an array. They'll all be replaced by their values. And again, the bound value is not going to arrive to the callback until all of the properties it needs are resolved. And that's primarily to deal with things like records being loaded, associations traversed. They can't give you that value, so they simply won't. They won't call you with null or empty or something like that. They'll wait till the value is available, and then they'll call the callback with it. So that's the mechanics of bind, and obviously there's other uses than components, but the primary use of it is at this level where we bring the view model into the component hierarchy and connect it up so that components can actually take advantage of bind and pull that value through in this way. So we've defined binding to components to be binding to configs. So when you see here is just a component, a button, some items array of some view somewhere, and it's got a bind config in there, and the text is the property, the config property that's being bound. And it's being bound to some bind descriptor. So that, on the right of that config property, is any valid bind descriptor. It will ask the view model, take this thing to the right, call me, and I know to set the text property or text config of this component. So the bind internals just process it in that simple way. Actually, if you look for where does it all happen, very little of it happens in component. It just looks at this and knows what you're connecting to what. So if you remember that you can supply bind options to the call direct to the view model, but when you're in a bind config, it's a little more interesting. You have to push the bound value, the bind descriptor down one into an object, and then that object serves as the options object. So you can say here, we've said deep, so this button will be called whenever foo or any child property updates. So that's how the options get passed in. So the first question is, okay, you can declare this on there, but where does that view model come from? Because you have to track one down. And the intuitive answer is it would come from that component or some container of that component climbing up the component hierarchy until somebody provides this view model. So that's what is going to happen here with, say, this example hierarchy. We're going to take the viewport. We've got a couple panels, toolbars, buttons, and grids. And we've associated two view models at those two locations in the component hierarchy. And they essentially kind of paint the hierarchy below with themselves. They become the view model that all of those components will use to perform bind operations. And the view models themselves are related so that the child view model has a connection to its parent view model. So any information placed in the root one will be available to the child as well. So basically, this is when processing our bind statement down at the bottom, it just looks up until it finds that view model there, and that's the place that the bind call is made. So basically, that's it for how components interact with a view model. They have a view model config. They'll create a view model if you tell it to, and then it will be inherited by all child components below that, and it processes bind configs in that view model. So that's really the interaction of the component hierarchy with view models. So like I said, most of the interaction you'll do with them is describing what you want in bind descriptors and then satisfying what you want by building out a custom view model. So the next step here is how do you deal with connecting up the view model and putting your information in it? So when you're wanting to lay out view models, you have to understand the hierarchy of view models, because a lot of times you want to share information maybe at the root. So if the logged in user is a piece of information that you might need all over the application in any view, you can put that at the root level view model as maybe the user, and then that will be available to children because of the parent-child relationship that will happen. And the way that's implemented is that each of the view models has a data object underneath it. So in the sense, it's very much like a model in the data package. It's just a wrapper around an object that holds its values. But it's much more involved than that, because for starters, when you have a view model hierarchy, you have a prototype chain between these objects. So that's how the user that you might put at the root becomes available to the view model below it, because it's simply in the prototype chain of the data object in the child view model. So that's going to be basically all that's needed to find that value when we go to do a bind from the child for this value that's not present. So to populate the view model, there's really a few ways. We've already seen this one, just set data into it, get a hold of it, call set, data goes in, and anybody that's bound to that will be updated. But there's a handful of configs that you can use when you're defining, I'm going to set up my view model and I want some certain behaviors and I'm going to provide certain information. It lets you take that out of your view. So there's a handful of configs that will see how to use to make your view model provide that information right out of the gate, so that the view just says my view model is so-and-so and it does all the work. So those configs are the data config, which just populates the data of the view model directly. Stores, those are going to create stores and put those in the view model as data object. Formulas do more like an object-defined property kind of behavior and put that value in the view model. And a link is more for loading individual records, and we're enhancing that slightly in 6. But those are the primary properties or configs of a view model that you would set, say, in a derived class in order to satisfy what your needs of your view are going to be. So data. So what we've got on the start off is I'm going to create a view. That view is going to specify a view model. The type is given there, and some data is also given there. To satisfy that, we have to have the view model And this is the normal way we do that. We take an alias, say ViewModel dot, I'm going to put this alias to it, and then the type on the left is the suffix, and that creates that instance on the right. So you can see here we've defined data on both sides, and just like any instantiation, the value from the point of instantiation is going to win. So this view is going to have 42 for the value of foo, but anybody that would create this without overriding that would have gotten 427 for the value of foo. So which one do you use? Well, it kind of depends. I would say the one on the right, if you're going to use this model in one spot. If you're going to use it in lots of spots, maybe some of those places need to define specific data for that specific place. And so it might be a mixture. You might have a value that other multiples will use, but only this view uses this value. So it's not a hard and fast answer, but generally I'd say in the declaration of the view models, your better bet when that works. So when we get down to creating the view, that's another spot we can, again, say, at the moment I'm creating this view, I'm going to also set some data. And this will take priority over even the definition we saw back before, and that's at instance time. So again, the question is, well, when do you know the value of the thing that you want to set? Do you know it at instantiation or declaration, and then get it in there? But this is also a fairly important point. Just like any config in ext, when you specify an object, this is merged with the one from the class, which allows the type to be specified by the class. So if we remember back here, ViewModel type main is going to come in from here. And that's important because you want your view to be in control of the type of ViewModel that it has. And so over here, we don't specify that. We could, but we want to inherit that value. All right, stores. This is one of the other most popular things to want to populate into the ViewModel, making stores available for grids, for lists, combo boxes, whatnot. So we specifically understand how to process a stores config on ViewModels. You simply name it, and the value of this is the bind descriptor. So anything that's in there, including filters and whatnot, can be dynamically populated by the ViewModel or from its parent ViewModel, et cetera. And then when that data is all available, that configuration for the store is turned into an actual store, put in the ViewModel by the name of bar, and now anybody bound to bar will update and be reconfigured to use that store. So obviously you can use clever things like filters here to get values that are dynamic coming into filters. But be aware that that value, if it's not initially set somewhere, will hold up the delivery of that store. Another way to define stores is to use our type alias. And so in 5, we've added the ability for types to be assigned to stores. And you can say, I'm going to create an alias for my store, and that lets me put a lot of the details back there in a store type. So I can create more than one of these. You could have always done a shared store instance, but if you need a different copy of it for some reason, this is a useful technique to just give me my own instance, not a shared one. So the type alias, and then anything on the left then is a bind descriptor, and that'll be applied on top of the type you have there. So then here's how it comes together. Basically, some grid, some place, binds, and you get bar. And I skipped over this briefly, but the bind config has a short form, which is not an object. And what that is doing is essentially setting some property. That property is whatever the default bind property is. So in the case of a grid, that's a store. Form fields, it would be the value config. So generally speaking, you don't need to put objects for the bind, but understand that each one will have a different idea of what's being bound. Right, so formulas. Another useful way, if you've met object-defined property, it's essentially a way to take a name and not have to call methods to get its value or set its value, but yet put methods underneath it so that the value can be determined from others. So the simplest form of a formula is like this. Basically, provide your get method to retrieve its value, and we'll give that function a get method, and that is how we know its dependencies. So when we're writing the twice function, we are given the getter, and we really do need to use it because it's the calls to that getter that are the dependency graph. So if you want this function to be called again to make sure that twice becomes twice x whenever x changes, we need to know that that's a dependency. And of course, formulas can use formulas. In fact, any dependency, it doesn't matter how it got satisfied. It could be data, it could be a formula, it could be a store. Any request for information will be delivered. It doesn't matter how it's populated. So formula to formula. To do the two-way binding of formulas so you can set it and get it, you have the ability to open that object up, put the get in the set again. Very similar to object-defined property, but again, use the getter. This will be called anytime its dependencies change. And the this pointer on your setter is how you're going to put the data back. That's going to be the ViewModel instance. So a very useful pattern would be that that setter can call this dot some helper method, and that helper method is defined on your ViewModel down below. It doesn't have to be set, it can be anything, as long as the goal is achieved by calling it. So the next one is links. Now, the links, we used them briefly in our data binding session, or not data binding, on the data session, to set up a child session. And the job of a link is essentially to supply records, and there'll be some enhancements to that. But the fundamental form of it, if you know, let's say a query string value is how you know that I'm supposed to be looking at ticket 427, I can put that in here and say my link's a reference to a ticket with ID 427, and that ticket will then show up as a record as soon as, again, the record is loaded. So it will look in the session if there is one associated, but that's how it's going to get the value and supply it. So ticket is the name of the value, and the load record is its result. All right. Now, this is actually the form we used in the data session. So we already had the ticket. Say we have a grid, we have a bunch of records in there, and I'm going to do a pop-up, and I need to send some data in to my form. So I'm going to send in a link to this record, and because of the child session involved, that link is going to link to that record. So again, if you weren't in that previous session, I apologize for skipping through that rather quickly, but with this record here, the ticket instance, I don't want to edit it directly. I want this form to do its own edits to a copy of it that's linked back to this one. So when we save that data, this is the instance. So it may copy if there is a child session involved. And lastly, for links, when we have more complex bindings, we can basically go through and set up a bind descriptor on the right, and then that value is the value. So if you find that you repeat bind descriptors in a few spots, you can set up essentially a link from one bind to another. And so the value of foo is an object with an A and B property. The values of those are satisfied by these. And so from there forward, anybody that wants that object can simply bind to foo, and they'll get that object. So they don't have to worry about how it's populated. So again, that'll be an ext6, but it's a fairly straightforward use of the bind that's already there. So again, that can be anything, any value you want. It's really reference that kicks it into, that's a record. If you say this reference is a reference to something, that means it's a record reference. So under the covers, I don't know if anybody's gotten under the covers other than Rob, who did the D3 session this far, but under the covers, all of the bindings get lumped into a thing called the scheduler. And the reason I figured it's useful to know about it is that you can actually tell it to run manually, but it's helpful to know kind of how this all comes together so that you can write formulas that behave correctly, because sometimes if your dependencies go into a cycle, you'll get errors from the scheduler. The scheduler will tell you that you have a circular pattern in your bindings and it can't resolve the result. And so just that's where that message is going to come from. So the scheduler is a shared thing that is at the root of any view model. So if a view model has a parent, it's going to use that parent scheduler. Otherwise, it'll create its one for itself. And the scheduler's job is really to track all of the binding instances. So the binding instances are any binding made at all. So if you've bound for foo, you'll find that binding is listed in there. If you bind to the ticket.reporter.name, what's going to happen is it takes that dot path apart and it does internally bind. So name will be bound to ticket reporter, or the reporter will be bound to ticket. So whenever ticket changes, reporter changes. Whenever ticket reporter changes, the name changes. So there's a variety of these little bindings, and the key is that they're ordered in the order of data dependency. So whenever you set up the formula that we saw before, twice is calling get on an X and quad is calling get on twice, what we're going to see is that those are ordered such that X is first, twice is next somewhere, and quad is further down. And so then the actual processing of this just runs through it forward. And all of the normal tests that we run, we ensure that that's going to be one pass. We allow for 5, but all of the acyclical bindings that you can do are going to run this in one pass. So the idea is that when the scheduler kicks in and runs, it has a lot of bindings, but only the ones that were marked dirty are going to be processed, and they're going to be processed in the order of dependency. So if X changes, we know X is dirty, twice is bound to it, twice is dirty, and it's going to be reevaluated just once. Quad is bound to twice, and it'll be reevaluated as it goes. So that's the pattern, and it ensures that just one reevaluation happens per change. And again, this also is asynchronous. So anytime those changes happen, they start accumulating, this happens later. So remember how we said when you vm.setFoo42, the only reason we saw the log immediately in the debugger was because the debugger released the time. If you are doing this in your app and you ask for the value, it's not there yet, hasn't been delivered, only later. So you can kick that into motion yourself with this call here. So this VM notify, that is going to be the way to kick it in and make it run immediately. So I don't know that you normally want to do that because, asynchronous, it lets different events queue up and cause values that might cause multiple layout runs if you do this directly to accumulate for a very short period of time, I think by default 50 milliseconds, something like that. And so after that amount of time, then whatever's dirty gets pushed through. And so basically, at this point, I'm going to try to go into the debugger, and then we'll hit some Q&A. So let's see if we can do some basic ViewModel stuff. It's a little bigger for the back. All right, so we're going to create a ViewModel. And then, so recalling what we had back in the earlier slides, we're going to bind to foo. And then function value console that value out. So remember that. All right, so there's our binding. Type error undefined is not. It's like everybody's saying the answer, and I'm just, let's see. So, yeah, that would slow this down. Okay. It'd help to have. That's why. That wouldn't be any better. All right. I don't recommend typing out of your peripheral vision. It's not a good one. All right, so now we have it. Now we're going. Okay, so nothing happened. I didn't see any log statements yet. And so we're going to set foo to be 42. And there it went. So it came out just because, again, they're relinquishing it. And you can tell it's not a quoted thing. It's 42 exactly. So now, do it again. We're called again, and on it goes. And so if I do that, of course, now Oh, that's no change at all. So that won't. And it does squelch calls to set that don't actually change anything. So now our binding isn't called because we're not bound anymore. So let's do a more interesting bind. Make an object. Boo. Array, object, oh wait, object. Whoa. Yeah. All right. I don't know about typing that one. I'll tell you what, I'll bring it over here and type it. Actually see it. Again, you've probably already spotted the, oh yeah, there it is. And the other one. All right, back to you. And we'll try and get on to some questions here. All right, so I got my binding in there, and there's the object. Let's see if we can open this up. So we've got an object, an array, value of x there, an array with hello42 as a string. So again, that was the bound value as a result. So we go call set, change foo. Okay, there's our object again. And both the properties are updated, of course. So that object gets reused and just updated by the internals of that bind. So that's it in a nutshell. And I think we actually have time for some of that, some question answers. So we have a mic. Hopefully learn something new, some trick of the trade, but all right.
I just had two questions. One, is there any documentation on the bind descriptors in, oh, I'll let you answer that one.
Yeah, it should be in the bind method documentation of the view model. The trick is that it might not be linked directly to the bind config of the component. So check the bind method of the view model.
Okay.
That would be where it's documented. Hopefully this clarifies the corner cases a bit, but.
Right. And also, I was looking through the documentation, and I noticed in the view model there was a config to specify a view controller, and a view. And in the view config, there was a configuration option to specify a view model. So they were kind of like you could specify the other one in each direction.
Okay, right. So the question is the view config of a view model, right? That what up?
Like,
so,
why would they both
right.
Why would I
well,
specify
because
one
they're
or the
aware
other?
of each other, and the reason that they are aware of each other is the connection to things like the session. Mm-hmm. So the session is another object that's similar to the view model in that it's set at some level in the component hierarchy, inherited to all of the children in the component hierarchy. So when you make a link to a record and you say, I want ticket 427, the first thing it's going to do is it's going to try and track down that session and ask, do I have a session? If I do, does it have 427 for the ticket entity type? If it does, then it immediately will acquire it. So that's why it needs that link back, but it's just an internal link back to its owner. The ownership is from view to view model through the view model config of the component. So that's the way you want to specify it.
Okay, thank you.
Sure thing.
Hey, Don.
Howdy.
So is there any way to specify for a store filter, can you use a function instead of passing in an array?
So the filters can be functions, yeah. Inside of a bind like this,
Yeah.
I suspect that would not be supported. My guess is because the bind descriptor doesn't accept functions, although it might just tolerate it and pass it on. I'm not positive.
I couldn't get it working so far. And that leads to my next question, which is, if I'm making a server call and it brings back a nested one-to-many sort of thing, Right now I'm having to manually listen to the load function for sort of the parent store and then unpack the menus. So if I have a list of countries and the countries have a list of cities and the list of cities has a list of Sencha developers, and and at some point I want to populate one individual grid with its list of Sencha developers per city, per country, I have to manually tease that out from the data. So I'm fetching it all from one REST call. And so filter, if I could use a filter function, I can then use store, sort of use a weird kind of store chaining to do that.
Right.
I played around with another thing where I hacked into ViewModel and created something declarative, but it doesn't go deep, so that didn't seem great. And then the last...
So let's keep one question.
I will, I promise, just one more nugget. And if I have to unpack those nested stores and create additional data that can be bound to, it would be a lot better to do that in the ViewModel instead of the view controller, but there is no innate access to the ViewModel scope from the store's load function, so I had to hack into ViewModel to add that. So I added a scope for the ViewModel, so when you hit the load event.
Well, it sounds like the fundamental disconnect there is more of a nested loading issue, so my guess is something about how the association naming is working its way down. So we'd have to look at how the model and association is declared, because there's some defaulting that goes on. And if you're using entity names, that helps get control of that naming. But if not, whatnot. But it sounds like an offline question. We'd have to actually look at the code and see how it's set up. But nested loading is absolutely supported.
Oh, it totally loads. It's just being able to bind it.
I'm sorry?
Being able to bind each model instance within the nested stores.
Well, once the nested loading comes in, if it is nested associations, then those associations will be auto-populated. And then the syntax
okay, yeah, we'll have to take it offline.
Right. So yeah, I'd love to take a look at the code, but that's, I think, what we'd have to do. But it should work. Nested loading should work. It should populate associations, should be able to go through them. Okay, next question. And okay, we have a few more minutes.
Regarding documentation and view models that sit really at the root level and are available through the whole application, is it possible to document the data that is available in the view model and will it show up in JSDoc configuration and documentation? Because when you have many developers on a project, you will need a way to document which data is available in the view model and it can be used, and what it is it a string, is it an int or something like this?
Right, so the question would be documentation of the properties of a view model. I'd say that you definitely can if you open up the view model class and you supply the data config and you put properties in there. You can at least put the comments and they'll look like properties of the view model. But really, if you think about view model's role, those properties are always going to be the ones that are in the data object. It's kind of like fields of a record. So I'm pretty sure you could accomplish that, but JSDoc doesn't have native understanding of view models, of course, or view model data specifically, but the best bet would be to just treat the properties as data and just say at property, or at property, or just, that's probably the default even, and document your data there. That's one of the advantages of putting the declaration of your data in the view model, actually, is it has one concise place to know what can my view use, that whatever is in its view model and up. So I don't know if that fully answered, but JSDoc does not have direct understanding.
Okay, thanks.
Sure thing.
I have like a two-part question.
Okay.
Basically, for a specific view, we were trying to use links to get model from the proxy loaded into the view model.
Yeah.
Is that the best supported way to do that?
Well, the links are primarily used to bring in models, maybe unloaded ones, but as you saw, if you have the loaded one, the primary reason for using a link to send it in is so that it remembers that it's not supposed to carry the record instance in. So if you're not using sessions and nested sessions, the difference between a link to a record and a data of the same name in that record is really, there's no difference. So it just takes the record, recognizes it's an instance, and sends it on in. So if you're trying to do a copy child session thing, a link is definitely what you want to do.
It just seemed like a shortcut way of loading a model from a proxy to get it to the view model. But the second part of the question is, given that the view opens up almost instantaneously while the model is still loading. And even with just that scheduler delay, is there a way to get a loading mask on a page or those components while that data is being retrieved?
Right, so the scheduler, I'd have to check, but I think the scheduler does fire events. There might be global events. I'd have to check, but it's a good request. I mean, we definitely have events that fire from the scheduler. I'm just not sure the best way to retrieve access to those events. So when the scheduler starts loading something, it'll fire a busy event, and when it's done, it'll fire an idle event. It's just that I think there's some challenges to getting the reference to the scheduler, basically, to listen to it.
Right.
So it would be a great thing to forward on to the view as an event of some kind.
All right, and a little bit unrelated, but based on the JetBrains plugin, using the links method, if I say like the user.name, it doesn't recognize it because it doesn't know, it's not in its view model. Is there a way to kind of increase that support or?
Right. Well, that one's a little bit out of my league. The good news though on the plugin is that it will have understanding of all of the syntax and semantics of all of these things. The challenge with that one might simply be the inheritance of view model data from a parent view model is a component hierarchy question rather than a class hierarchy question. And so it could be that you won't know a global one. But I think with some extra annotations, to say, well, this one's always going to have one of these kind as its parent view model, we could seal that up better.
Okay,
but I'm not sure that Mark's done any of that just yet.
Okay, thank you.
All right,
Hi.
this will be the last question,
So,
but I'll be in Centra Zone afterwards, so fire away.
How can we define the multi-dependency on two stores so that when both the stores are loaded, then a function should fire to do something?
Okay, I'm not sure I understood the question. Sorry.
So we have two data stores and we want to define a multi-dependency on two stores. And when both the stores are loaded, then a function should fire. Usually the bind descriptors allow you to define one store. But let's say we have some logic which depends on two data stores coming from server and then.
So the question, how do you tie together two store loads and
then there should be a bind with a function which does
Right.
something.
So one way to accomplish that would be a formula, because whenever you call the get that it's given to you, you ask for the two stores you want, and it knows that this formula is dependent on both of those stores. So again, the loading behavior of the view model is for store, wait for the initial load and then deliver that store. So that formula should be evaluated only when both stores are loaded, and then it can result in whatever it needs to result in. Whatever you return will be stuck into the view model by the name of that formula. So that's one way to go about it, to use the binding to tee together those two things. Again, that's because all bind descriptors block until all of their replacement tokens are satisfied. And that's true of formulas as well. All of your get calls will need to have data before we call you, and then you'll know that all of those can be evaluated. So, all right. Well, thank you very much, everybody, and see you at Centra Zone.